Hello there. I'm going to start a new video series going over trig identities. So this is our identity for the day, and we are going to prove or disprove it. So I notice on the left-hand side, I have a difference of squares. So on the left-hand side, I am going to go secant squared x minus tangent squared x times the quantity secant squared x plus tangent squared x. Now, this right here is 1 from our Pythagorean identity, so we're just left with secant squared x plus tangent squared x. Now, I can take this part and I'm going to substitute in its Pythagorean identity, so that'd be tangent squared x plus 1, and then I still have this other tangent squared x, and I have this plus this is 2 tangent squared, giving me 1 plus 2 tangent squared x, and I am done. Hello there, we're going to go over this identity today. Now, I think the best approach for this one is to worry about the right-hand side of the equation. So in this, I'm going to use the Pythagorean identities for tangent squared and cotangent squared. That would be secant squared x minus 1, and I'll put it in parentheses for now, minus the cotangent is cosecant squared x minus 1. Now I'm going to go ahead and distribute this negative so I can drop the parentheses. That's secant squared x minus 1 minus cosecant squared x plus 1. And we can see the negative 1 and the 1 cancel, and I'm left with secant squared x minus cosecant squared x, leaving me my left-hand side, and we're done. Here's an identity I like. We have the sum of two trig functions equal to the product of those same two trig functions. When approaching a problem like this, I always like to deal with the one that has the sum on it. So we're dealing with the left-hand side on this one. I'm going to write this in terms of sine and cosine, and I'm going to try to find a common denominator out of it. So this would be multiplied by sine squared x in both the top and bottom. This would multiply by cosine squared x in the top and bottom. And now notice, because we have the same denominator, and I've got sine squared x, I can write them all in the same numerator now, and I've got my main Pythagorean identity here, so I get 1 over sine squared x times cosine squared x. Now if I do a little rearranging, I've got 1 over sine, which is cosecant, and 1 over cosine, which is secant, and that's my right-hand side. Here we've got an interesting identity to try and prove or disprove. We've got two binomial terms here, and it's going to be tempting to want to FOIL it out, but take close to what we have here. This right here is just the negative of 1 minus cosine squared x, and if you remember your Pythagorean identities, this right here is just sine squared x. So we got negative sine squared x, and then this right here is just the Pythagorean identity that gives us times secant squared x, and then expanding on it a little bit more, negative sine squared x will turn secant into cosine, and this will give me negative sine squared x over cosine squared x, which gives me a negative tangent squared x, and that's the same as what I have on the right side, and we're done. All right, I'm really a fan of this identity here. We've got one of almost every trigonometric function in here. The only one we're missing is cotangent. Now, obviously, we're going to want to work on the left-hand side because there's more going on that side, but let's keep in mind, on the right-hand side, we've got two tangents, okay? Now, we get a tangent out of here. So that's tangent x. So we got 1 down, 1 to go. We basically have to show that this right here is equal to tangent x, and we're done. So let's go ahead and do that. So I'm going to write it in terms of sine and cosine. So that's 1 over cosine x in the numerator, and then 1 over sine x in the denominator. Let's go ahead and simplify this complex fraction by multiplying top and bottom by sine x. So this cancels. We're left with 1 times sine x gives me sine x over cosine x, and once again we get this to be equal to tangent Finally x. Did it. I found an identity where all 6 trig functions are involved. So let's go ahead and FOIL this right here. I've got the sine x times the secant x. So sine x times 1 over cosine x, that gives us that's tangent x. Sine times cosecant x, that's a plus 1. Okay, great. Let's go ahead and work on the cosine now. Cosine times secant, that's another plus 1. And then we get cosine times 1 over sine x. So then we're going to write out the rest, minus cotangent x minus 2. And we can cancel this out. This right here will give us 2, but then we subtract this 2, and that cancels. So we're just left with tangent x on one side, which equals the right-hand side, and we are done. Okay, so let's go ahead and solve this identity. Now, when you get a fraction equal to a fraction, it's tempting to want to cross-multiply, but the more common and traditional element to do is to go ahead and multiply by the conjugate here. So we're working mainly on the right side, 1 minus sine x. Now, I'm not going to distribute the cosine cubed x, so that's cosine cubed x times 1 minus sine x all over, distribute this. This is effectively a difference of squares. So we get 1 minus sine squared x, and now we've got a Pythagorean identity, or an alternate form. Now, 2 of these will cancel, and this will cancel, so I'm left with, let's remember that, so I can transform this into 1 minus sine x all over secant x, and we get the left-hand side, which means we're done. In an identity where we have a sum equal to a product, I always like to deal with the side of the sum. It's easiest to deal with. So we're dealing with the left-hand side. We're going to write it in terms of sine and cosine. So what we're going to do is multiply to find a common denominator. So this will be cosine x, and this will be cosine x. This will get multiplied by sine x, and this will be sine multiplied by sine x. So we get here, now that we have our common denominator, is what we have in the numerator is a Pythagorean identity that's equal to 1. So 1 over sine x times cosine x. Now, what we have here, if we could split this into 2 fractions multiplied, we get 1 over sine x times 1 over cosine x. So that finally would give us, when with a little rearranging of 2, secant x times cosecant x, which is our right side, which means we're done.